Hey everyone, welcome to today's math lesson. Just before we get started, if you haven't done the quiz yesterday, make sure that you get that done. Quite a few kids have submitted it. There's only 3 questions. Make sure you do those 3 questions, and there's a 4th optional one, kind of an extending bonus one if you want. And I'll mark those this weekend, and I'm not sure how we'll get the marks back to you. If you want to know, you can always just ask me and I'll let you know. We're not really super worried about assessment. I just want to check in to see how you guys are doing. So it seems like through conversations and emails and having a few Google Meets that everybody's getting this. Most people are getting this. If you're not, then let me know because I want to help. I really do. And we have Mr. Hyde and the LSS department, some EAs that are willing to help. So let us know. We have our time each day, what do we call it? Our office hour time each day from 10 to 12. Mrs. Olson's first hour, I'm the second hour. And very few students are showing up for help, which seems to imply that you don't need help. But if you do, make sure you're there. Anyway, on to today's lesson. Okay, so we've been working on volume. We originally did surface area, like the surface area of a rectangle or a square or a trapezoid. And that's the number of squares that will fit. For example, if I have this 2 by 2 front of this box here, right, 2 centimeters by 2 centimeters, what that means is I can fit 4 centimeters squared there, 4 square centimeters, right? 1 by 1, 1 by 1, 1 by 1 by 1. And I can do a shortcut by multiplying 2 by 4. On this side one here, I can fit 4 by 2. So if I drew a different version of this side, I can fit 4 centimeters there, right? 1, 2, 3, 4, all along the side. That's the surface area, the 2-dimensional. How many squares can we fit? When we do 3-dimensional, it's how many cubes we can fit. So if I was making this shape 3-dimensional, right, it would be how many cubes can fit on this, right? So now I've got cubes here, like these 3-dimensional cubes. That's surface area, or pardon me, that's volume. That's the difference between the two. Now today we're going to do almost a combination of the two. We're going to continue a little bit with our volume, but we're going to do something called surface area of prisms, or surface area of 3D shapes. And I made a little, oh, it fell apart on me here. I made a little box here that's color-coded just to illustrate this, okay? So, I put some tape on here that's falling apart on me, but we'll see if we can hold it together. So I've got this rectangular prism, and the first thing you might notice is color-coded. The bottom is blue, the top is blue. They're the same dimensions. They have the same surface area. The side is red, this side is red. They're the same dimensions. They are equal in all respects. And then the front and the back, or whatever you would like to call these, the green ones, they're also the same. So what I have is a 6-sided figure, because it's a rectangular prism, 3 pairs. All of those are the same. So if I can figure out the surface area of this, I can times it by 2, and I'll get the surface area of the front and back. Get the surface area of this, times it by 2, and I get the surface area of the sides. Get the surface area of this blue one, right? Just altitude times base times height, length times width, whatever. Multiply that by 2, and I get the top and bottom. Okay, now, we can also draw this out 2-dimensionally, this 3-dimensional shape. If I were to cut along the lines, take an X-Acto knife, and I've already done that for us, and open this up, this is what the shape looks like, okay? So this blue here is the bottom of the shape, right? These green are the sides, or the front and back, and the red are the sides. Okay, and this other blue is the top. So I get this thing that looks like a cross. Isn't that very nice? It is Easter time. I can get the surface area of each one of those shapes, right? This is called a net, a geometry net, and it's a rectangular prism. You have a different one for a triangular prism. You have a different one for a cylinder, but this one today is a rectangular prism. So what I need to do is get the surface area of this, okay? Multiply it by 2, that will take care of those 2. Get the surface area of this, multiply it by 2, that takes care of those 2. Get the surface area of one of these, multiply it by 2, and that takes care of that. That's my whole 3-dimensional shape. That's my prism. That's the surface area of a prism. So let's look at it one other way here. This is just a 2-dimensional drawing on the board. I have a 2 by 2, so a square on the front, by 4. Now if I were to draw this out, getting volume would be easy, right? 2 times 2 is 4 times 2, the depth, that would be 16 centimeters cubed. That's how many cubes would fit inside, but I want the area on the outside, the surface area of all 6 of the outsides. So I could draw this out, and we're going to practice a little bit of that. Now this is the bottom, so this is this bottom area right here, and it's a 2 by 4, okay? Now, if I open this box up, this side right here, the depth or whatever this side would be called, right, is another 2 by 4, and I can draw that right underneath. Okay, so another 2 by 4. This is 2, 2, 4. Okay, that's the bottom and this side. Now I can also draw the back side of that, which would be up here. Okay, and that would be another 4 by 2 by 2. So I've got the bottom and this side and the back side, right? Now if you look, I also have these front and back sides attached to the bottom. So this is my bottom, and they are little 2 by 2s, little squares, okay? So they're all the same on all 4 sides. Okay, little 2 by 2s, right? So now I've got 5 of the 6 shapes, and all I need is the top. And the top is the same as the bottom, which is this right here, and it will be attached to one of these sides. It doesn't matter which one. Usually we draw it down here, okay? And that's a 4 by 2. Okay, so this is called a net, and I want you to try drawing a couple of those on the worksheet today. And then to get the surface area of this, I would just get the surface area of this shape right here, okay? So that's one of the sides, which is 4 by 2. And you can write it out if you want, base times height, 4 times 2. Area, surface area of that is 8 centimeters squared, okay? That's that one. And then times it by the other side, right? If that's this side, then you have 2 of those. So the area of that is 16 centimeters squared. So we've got those 2 sides covered. This one and this one, okay? How about the top and bottom? So the bottom and top. I've got the front and back. Now I'm looking for the top here and the bottom here, okay? And that is another 2 by 4 rectangle. Same thing, exactly same. So we can set up the formula just the same way. And the bottom and the top are both 8 square centimeters. So together, they are another 16 centimeters squared. And then I have the ends. So this end right here, okay, is getting really messy. And this end over here. And there are 2 by 2s. So the area equals base times height, 2 times 2. Those are 4 centimeters squared. 4 centimeters squared. So together, these are 8 centimeters squared. So to get the surface area of this whole shape, I would have 16 plus 16 plus 8. So that's 40 centimeters squared. Okay. Now it's just an intro today. We'll do more work on this next week. But I thought we'd set this up. We take this net here, and we can put our net back into a rectangular prism. We would do it like this, right? You can see how it all comes back together, right? This folds over, kind of like a shoebox, okay? And now we have a rectangular prism. 3 pairs of the same surface area sides. Now, one more thing before I end this video. If I have a triangular prism, it's going to be a little bit different, right? If I have a triangular prism, there's less sides, okay? Right, here we have, how could I do this dotted in the background here, right? These are the lines you can't see because it's in behind, okay? Oops, that's not a very good triangular prism, is it? It'd be more like that. Okay, anyway, I have front and back. So this time, if I draw the base, right, I draw my rectangular base, okay, or the bottom of this. On each one of those, I have a triangle that folds down like this, okay? Now those are the triangle ends. And then I've got 2 sides, 1 on each side. So for a triangular prism, it looks like that. And you can see how I could fold these all up. I could fold these into this and fold these ends up. And I'll make one next week, 3-dimensionally, so I can show you that way. A rectangle, or pardon me, a cylinder, maybe I'll erase this, have a little bit more room. A cylinder is a little bit like that, but even different. A cylinder is kind of weird. If I were to take this cylinder here, obviously it's made of 2 circles, right? 1 circle, 2 circle. And if I were to cut a line right here, think of a Diet Coke can or a pop can, and open it up, then what I end up with is a rectangle, okay? And the rectangle is the same as the circumference of these ends, okay? That's going to be the circumference. And then to each one of these, I have the circle. So I have a circle here, and I have a circle here, right? And I put those 3, whoops, I did this wrong. Sorry guys, running in real time here. For my cylinder, I'm running out of space, I think that's my problem. So here's my cylinder. If I cut it along here and stretch this rectangle out, it looks like this, right? There's the circumference. And then I have these circles, 1 on each side. So the circles would go there and there, okay? But there's more of that to follow next week. That's just kind of an intro, okay? If you have any questions, let me know. There's a 3-page kind of, there's a PDF. It's 3 pages. 2 of them are explanation pages, much like we just talked about here. If you're not sure about this, read through them. They're really quick. They've got some examples. And then the 3rd page is just the exercise page for today. I've also attached that separately too, so you can just download the exercise page if you want and work off there. Last reminder, on Friday, which will be today, you guys are watching this on Friday, we're going to have our classroom meets. So go to Google Meet. The code is Claiborne8J, and classroom times I think are 1 and 2 o'clock, but check on the website. Make sure you're checking the website every day and Google Classroom every day. Okay, take care guys.